Picture this. You look up at the night sky, expecting to see that familiar, comforting orb. But it's gone. Vanished. The moon, our silent guardian, our cosmic companion for billions of years, simply isn't there. What then? How would this profound, impossible absence reshape our world? Would the tide still rise and fall, or would our oceans become a chaotic, untamed force? We take its presence for granted, a constant in the cosmic dance. But its disappearance would be more than just a missing light. It would be a cataclysmic alteration of everything we know. A silent, crushing void where a world once hung. Imagine the sheer, terrifying emptiness. What would happen to Earth? The moon isn't just a pretty face in the sky, it's Earth's crucial stabilizer. Without its gravitational tether, our planet would begin to wobble like a top running out of spin. Scientists call this axial tilt stabilization. For billions of years, the moon has kept Earth's tilt remarkably constant, around 23.5 degrees. This precise tilt is responsible for our stable seasons and predictable climates. Without it, Earth's axial tilt could swing wildly, from nearly 0 degrees to 90 degrees over just a few million years. Imagine a world where the North Pole suddenly pointed directly at the sun, then years later, directly away. This isn't just a change in weather, it's a complete planetary upheaval. What would become of life's delicate balance? If our axial tilt became extreme, parts of Earth would experience perpetual daylight for months, while others endured endless night. Imagine regions perpetually baked by the sun, turning into vast, lifeless deserts. And conversely, other regions plunged into eternal twilight, freezing solid. The current stable tilt gives us our temperate zones, allowing for the incredible biodiversity we cherish. Without it, these zones would vanish. Crop cycles, migration patterns, even the very evolution of species, are all tied to Earth's consistent seasons. This isn't just a bad summer, it's an ice age followed by a desert furnace, all within a few thousand years. How could any complex life adapt to such relentless, unpredictable extremes? Beyond axial stability, the moon is the primary conductor of Earth's tides. Its gravitational pull creates the familiar ebb and flow of our oceans, shaping coastlines and influencing marine life. Without the moon, solar tides would still exist, but they are significantly weaker, about half the strength of lunar tides. The rhythmic, predictable dance would cease. Instead, picture chaotic, unpredictable surges and retreats of water, driven by the sun and the planet's own rotation. Our coastal ecosystems, from mangrove forests to coral reefs, are utterly dependent on these lunar cycles. The loss of stable tides would devastate marine life, leading to mass extinctions and profoundly altering ocean currents. What would happen to the very cradle of life? The moon's gravitational pull doesn't just affect surface water, it also subtly flexes Earth's solid crust, generating a tiny but measurable, solid Earth tide. While imperceptible to us, this constant flexing contributes to geological processes, potentially influencing volcanic activity and seismic events over geological timescales. Without the lunar stress, these internal dynamics could shift. Furthermore, the moon's influence on ocean currents is profound. The lunar tides drive deep ocean mixing, bringing nutrients from the abyssal plains to the surface, feeding vast ecosystems. Without this constant churning, vast ocean dead zones could expand, suffocating marine life and fundamentally altering the global climate through changes in heat distribution. How would the planet's very heartbeat change? Beyond the dramatic geological and climatic impacts, the moon plays a subtle yet profound role in the very rhythm of life. Many nocturnal animals rely on moonlight for hunting, navigation, and even mating rituals. Imagine a world plunged into true darkness every night, a darkness only broken by the unfiltered brilliance of countless stars. Without the moon, the night sky would be a spectacle of unparalleled starlight, but for many creatures, it would be a terrifying void. Entire ecosystems built around lunar cycles, from coral spawning to insect navigation, would collapse. This cosmic light switch isn't merely about ambience, it's about survival. What untold ripple effects would such a fundamental change unleash across the web of life? But how did Earth acquire such a vital celestial companion in the first place? The prevailing scientific theory is the giant impact hypothesis. Approximately 4.5 billion years ago, a Mars-sized protoplanet, now known as Theia, collided catastrophically with early Earth. This wasn't a glancing blow, it was a cosmic hammer strike. The impact was so immense that it ejected a vast amount of molten rock and debris into orbit around Earth. Over time, this ejected material coalesced under its own gravity, forming the moon we know today. This violent birth explains the moon's composition, which is remarkably similar to Earth's mantle, and its relatively low density. It was a cosmic accident, a collision that fundamentally shaped our future. Could such an event ever be undone? The moon's existence is a testament to the violent, chaotic birth of our solar system. This giant impact hypothesis isn't just a story, it's supported by overwhelming evidence, including lunar rock samples brought back by the Apollo missions. These samples reveal a composition strikingly similar to Earth's mantle, but with a depletion of volatile elements, consistent with a high-energy, high-temperature formation event. Without this colossal cosmic collision, Earth would likely have no large moon. Our planet might spin much faster, leading to incredibly short days, perhaps just a few hours long. The very definition of a day would be radically different. Imagine a world where the sun rises and sets several times before you finish breakfast. How would that reshape life, consciousness, and even the pace of evolution? The moon also acts as a gravitational brake, slowly but surely slowing Earth's rotation over billions of years. In Earth's early history, a day lasted perhaps only 6 hours. Without the moon's tidal friction, our planet would still be spinning at a dizzying pace, leading to extreme Coriolis effects that would generate superstorms and fundamentally alter weather patterns. Imagine winds that constantly howl at hurricane force. The very concept of night as we know it would be fleeting, a brief twilight before the sun quickly re-emerges. This faster rotation would also flatten Earth slightly more at the poles and bulge it more at the equator, subtly changing its shape. How would such a rapidly rotating, tempestuous world support complex life? Such a rapidly spinning Earth would also have a much stronger magnetic field, generated by its faster-moving molten core. While a strong magnetic field is good for protecting against solar radiation, the constant, extreme weather would be a relentless challenge for any life to overcome. Life, in its incredible adaptability, would undoubtedly find a way. But it would be a very different kind of life, perhaps clinging to sheltered valleys or deep underground, far from the furious winds and chaotic climate. The evolutionary pressures would be immense, forging species unlike anything we see today. The very concept of a calm day might be utterly foreign. Our moon, in its quiet presence, has gifted Earth with a stability that allowed for the slow, gentle unfolding of complex life. What a profound gift it has been. What if, in a distant future, humanity itself became the agent of the moon's disappearance? Imagine a scenario where advanced civilizations, perhaps seeking resources or terraforming distant worlds, somehow engineered its removal. This isn't science fiction anymore, but a thought experiment on the potential hubris of a highly advanced species. The energy required to move a body the size of the moon is astronomical, a feat far beyond our current capabilities. But what if? Would such a civilization fully comprehend the intricate, delicate balance it would be shattering? Or would they discover, too late, the true cost of tampering with cosmic architecture? The moon is not merely a rock, it is a keystone in Earth's grand design. Would we recognize its value before it was gone? The moon is not just a passive observer, it's slowly but surely receding from Earth at a rate of about 3.8 centimeters per year. This isn't a sudden departure, but a glacial drift, a cosmic ballet playing out over eons. As the moon moves further away, its gravitational influence on Earth will gradually weaken. The tides will become less pronounced, and Earth's rotation will slow down at an even slower rate. Billions of years from now, the moon will be so distant that it will appear much smaller in our sky, perhaps too small to cause total solar eclipses. It's a slow, inevitable separation, a cosmic farewell stretched across unimaginable timescales. But even this slow retreat underscores its current, irreplaceable role. What happens when our cosmic tether finally loosens its grip? So, what if Earth lost its moon? The scientific consensus is clear, it would be a catastrophic cascade of events. Our axial tilt would destabilize, leading to extreme climate swings. Our oceans would become chaotic, and the very rhythm of life would be irrevocably altered. The moon is not just a beautiful ornament in our sky, it is a fundamental architect of our planet's stability, its climate, and ultimately, the conditions that allowed complex life to flourish. From its violent birth to its slow, steady retreat, its story is intertwined with our own. Its presence is a cosmic gift, a constant reminder of the delicate balance of planetary dynamics. We owe so much to that silent, spherical companion. The moon's gravitational embrace is a constant, subtle force that shapes every aspect of our world. It's a reminder of the interconnectedness of the cosmos, how a single celestial body can profoundly influence the destiny of another. Its stability ensures our seasons, its tides sculpt our shores, and its light guides countless lives. This isn't just astronomy, it's the very foundation of our existence. So next time you gaze upon the moon, remember not just its beauty, but its vital, undeniable role in making Earth the unique, life-sustaining planet it is. A world without its moon is a world utterly transformed, a testament to the profound power of celestial mechanics. Its presence is a silent, cosmic miracle. Our journey through a moonless Earth reveals a chilling truth. The moon is not merely a satellite, it's an indispensable partner in the cosmic ballet of our solar system. Its gravitational dance orchestrates our planet's rhythm, from the length of our days to the stability of our climate. This intricate relationship, forged in the fiery crucible of a giant impact, is a testament to the delicate balance of forces that allow life to thrive. So, next time you look up, remember the moon's silent, profound influence. It's a constant reminder of how interconnected we are, not just to each other, but to the entire universe. Its presence is a cosmic miracle, ensuring our world remains a vibrant, habitable haven.